Okay. So yesterday we've started introduced the integral by parts. The formula is u dv equals uv minus v du. Okay, and we're going to look at more examples. For example, if I have x sine x dx. Okay, so here there is a that is kind of like a technique, that's trick or method you can think about. You can always use, like you can say, okay, that's what I'm supposed to do. You always want to do the x as your u. Okay, because you see this one du just dx. Normally you will always want to do the x as a u. So do u equals x and dv equals sine x dx. Okay, if dv equals sine x dx, then you can write this one as x d over cosine x. But d of cosine give you what? Well, from here you can solve for v equals actual negative cosine x. Okay, from here you can solve v equals negative cosine. Take the antiderivative. So d, this is the u, this is dv. And how you find a v equals that? So dv, use the formula. Formula is u dv, right? So you just plug into here, so the d of negative cosine x. Okay, then you use the formula uv minus v du. uv, so it's x negative cosine x. This is not a minus, multiplication. And uv minus v du. v is cosine x negative, and du, u is x. And then you have negative x cosine x plus antiderivative of cosine x is sine x, and plus c. That's it. Okay. Let's look at next example. X ln x dx. This is a special case. You will not want to do the x as your u, because if you do dv, for example, I use integral by parts, right? If I use integral by parts, for example, you want to think, how about just let u equals x and dv equals ln x dx. Now I want to find a v. What is v? Take the antiderivative on both sides. Take the integral. Well, what's the antiderivative of ln? We only know the derivative of ln is 1 over x, but the antiderivative of ln, we don't know that. Okay, so it doesn't work. So now how about we try the other thing? Just let u equals ln x and dv equals x dx. Because this is a u, then the other two will be dv. Now I solve for v equals, take the antiderivative on both sides, take integration, so it's half of x squared. Well, you probably say, oh, I have plus c. It doesn't matter when we apply here. You don't have to write down the plus c into when you solve that problem, because you would just want to know what is the v function here. So, and it still has an integral, it contains that c. So now let's do the antiderivative by parts. So u dv. So I have ln x d over v is half of x squared. Why I don't contain the c here? Because I still have an integral here. So the c is contained in the whole integral. I don't have to contain the c. Okay. So u is ln x. v is half of x squared. Now I use the formula. u dv equals uv minus v du. Alright, so now you have u, this is u, so it's ln x, 1/2 x squared. These two, you cannot combine them together because this is ln function, this is a polynomial function. And uv minus v is half of x squared d of ln x. Derivative of ln is half of x. Sorry, it says 1 of x. So it's half of x squared times derivative of ln is 1 over x dx. Then you cancel it out. The final answer is ln x. You just take it out. Half of x squared can put it in the front. So half of x squared ln x minus this one, reduce it. So half take in the front, you got an x. Okay, so just x dx. This is a simple one. I just write one more step. Half of x squared ln x minus half of x squared over 2 plus c. And this you can change it into x squared over 4, right? So it's x squared over 4. That's how you do this one. Does it make sense, everyone? Okay, I'll write one more example. I'll write an example, let you practice by yourself. How about next example, I want you to practice one, make sure you understand it. So if you have x e to negative 2x dx, can you practice this one? Okay, are you done? So this one, we can find that u equals x, dv equals e to negative 2x dx. Okay. Sometimes you just try a little bit, but this, you know, if you take the derivative of x, it's going to be 1. Okay. So you take this one as dv, you find v, take the integral on both sides, you get e to negative 2x over 2, negative 2. You probably have a c, but here we don't really right? I see here because it's still I have an integral here. So now, according to the formula, it's going to be x d of e to negative 2x over negative 2. We should write that into this u dv form. Then it's uv, so it's x times v is negative 2e to negative 2x uv minus v du. So it's e to negative 2x over negative 2 du. U is x, so it's x. And then we have the whole thing is negative half of x e to negative 2x minus minus is plus half of e to negative 2x dx. Well, exponential function is just itself. So x e to negative 2x plus half of e to negative 2x divided by the chain rule on the negative 2. So it's divided by negative 2 again plus c. The whole thing is just negative 2 x e to negative 2x minus 4 e to negative 2x plus c. Did you all get the same thing? Yes? Okay. So next I will introduce you what we say is we call it Tabular method. Okay. Yesterday I was told you can go back and review that method and see what the method is talking about. Now we're going to use the tabular method here. Okay. Can we move on? Okay. So now I'm still looking at the same problem. So same problem. X e to negative 2x dx. Let's use tabular method. Since yesterday I asked you to go back and read the book and think about this method, can anyone tell me how you use tabular method to solve this problem? Can anyone try? Anyone wants to try? Yesterday I said please go back and read the textbook, and tomorrow we'll look at this and focus on tabular method. No? Okay. So tabular method, basically you don't do the UDV, that part. That's just, we simplify that whole process. Okay. Tabular method, you net U equals X. Okay. This is dV. dV is e to negative 2x. Okay. U dV, right? Just x e to negative x. For u, you take the derivative. For dV, you do antiderivative. Okay. So derivative of x equals, what is the derivative of x? Anyone? Okay, 1. Very good, thank you. What's the antiderivative of e to negative 2x? E to negative 2x and over negative 2. Thank you, Taylor. Very good. Now, we'll continue. What's the derivative of 1? 0. Thank you very much. What's the antiderivative of e to negative 2x over negative 2? So e to negative x, 2x over negative 2, you have another negative 2 again, so it's e to negative 2x over 4. Okay. Now, what do we need to do? We have use the sign is plus, alternative, minus, plus. Okay. And then cross. Okay. Alternate cross, uv. That's u, that's v. Because this is dv. So this is uv, uv, like that. Then your final answer is x times that. So you just multiply those two, uv, you multiply that. So x times this. So x times negative 2 e to negative 2x. And minus e to negative 2x over 4. And you have one more 0 here. But this is 0 multiplication, so there's nothing here. And then we'll have 0, so just plus c. And then we're done. Okay, you got exactly the same answer as the previous one. Do you like this method? Okay. Let's practice several problems. So example, x squared cosine x dx. Now, we still use tabular method. U dv. U is x squared because you take the derivative of x squared, go to 2x, go to 2, go to 0. Okay? And dv is cosine x. Derivative of x squared is 2x. Derivative of 2x is 2. Derivative of 2 is 0. Just keep going until it's 0. Okay? Antiderivative of cosine is sine. Antiderivative of sine is negative cosine. Antiderivative of negative cosine is negative sine. Okay? And you have plus, minus, plus, minus. Okay, match it. The final answer is going to be x squared sine x and the minus minus is a plus. 2x cosine x plus minus is minus. Minus 2 sine x plus c. And we're done. Does that make sense, everyone? Okay. This is the one type of question. Whenever you have the type of, whenever you have just a summary here, whenever you have the form like x power n e to ax dx, okay, and x power n sine ax dx, or x power n cosine ax dx, this kind of form, okay, you always let u equals x power n, v equals the other one, e to ax, or sine ax, or cosine ax. That's what you do for all kinds of this form. Okay, it covers a lot of integrals. I want to use the tabular method to try one by yourself. I want to try the tabular method with x cubed sine x dx. Can we try the tabular method and solve this one? Okay, so we use Tabular method. We use u is x cubed. This side you do derivative. This side you do antiderivative. Okay. So what do we do? X cubed continue 3x. Sorry, oh my, I did it wrong. So 3x squared, 6x, and 6 and 0. Sine x, antiderivative sine is negative cosine. Antiderivative of negative cosine is negative sine. Okay, because derivative sine is cosine, right? Antiderivative that is negative sine. So antiderivative negative sine is cosine. Antiderivative cosine is sine. So derivative sine is cosine. Okay. Now, do you got the same thing, everyone? Yes? Okay. So we can do plus, minus, plus, minus, plus. So cross, cross, cross. Oh, this one does not cross here. Cross and cross. Okay, your final answer is negative x cubed cosine x minus 3x sine x minus minus plus. Sine x by plus is plus 6x cosine x minus 6 sine x plus c. Have you all got the same answer? Okay, very good. Let's continue look at the previous one. The one we just did in the beginning of the class. Wait, not x sine x because that's too simple. X, ln x. Let's look at this one. X ln x dx. Use Tabular method. Well, this is a little bit different because in this one, you think about, oh, I'll just try u equals x. X derivative is 1, derivative 1 is 0. That's perfect. I like that. And I have a 0 in the end. But think about the ln x. When you take the antiderivative ln, you don't have anything for that. Okay, so here we just do u equals ln x because I have the derivative for ln, not antiderivative for ln. So derivative of ln is 1 over x. Okay, you probably think about it. If I continue taking the derivative of 1 over x, it's going to be negative 1 over x squared. I don't want to continue until I think I should. Okay, then what do I do? For dv is x squared. So it's x. My bad. The antiderivative of x, this is u, this is dv. This side I do derivative. This side you do antiderivative. So antiderivative of x is x squared over 2. And plus, minus. You think about that, it goes that, right? You think, oh, this is not a 0. What if it's not? What if it is not a 0? It's okay. You just put those together, and last step is the antiderivative because the formula is u dv equals uv minus v du, and this is the v, this is the du. So it's pretty simple. If it's not 0, we just put them together, put the antiderivative. So now what I do, I still have ln x times x squared over 2. You just put these two together. Plus, well, this is the minus. Okay, so minus these two together, 1 over x squared over 2 dx. You may ask me, oh, previous why I don't have this antiderivative in the end? Because the previous you have a 0. Okay, don't need that. But now if it's not a 0, what do we have? We have to put the last step as a v du part. But it's much simpler as you find a u, find a v, and do all those antiderivatives, right? Especially if you have to do the integral by parts several times. So now it's much simpler. You still have the same thing, ln x squared over 2. It will be the same answer. Okay, so cancel this one. Is going to be x over 2 dx. The final answer will be still the same as your previous one, but it's simplify the process for u dv. It's more straightforward doing the Tabular method. You can use the Tabular method for any integral by parts problem. Okay, x squared over 2 over 4 plus c. Okay, now I want to try this one by itself. X squared ln x dx. I want to try this one by itself. Alright, so I would like anyone tell me, can anyone tell me how you did it?
So I said ln x equals to u and the x squared is the dv then.
Yep.
And the derivative of ln x is just going to be the negative 1 over x. And the antiderivative of x squared is x cubed over 2.
Very good. Okay, so equals what, Taylor?
Ln x times x cubed over 2 minus 1 over x times x cubed over 2, which can be simplified to ln x times x cubed over 2 minus x squared over 2 plus 2.
Yep, this is x squared over 3 dx. The last step is antiderivative. Don't forget that antiderivative have to take one more step. Okay, it's not just look together because this one goes back to u. Okay, if it's cross, it's uv, but if it goes back to u, it's v du. Okay, so x, pretty simple, right? This method is much better. Oh, I don't have a c here because I have a derivative. I need to end up here. So it's x cubed divided by new thing 9 plus c. Okay, so it should be a simple one. So now, for the second type of integral, let's do a summary here. Whenever you have x power n, ln x dx, or x power n, arc sine ax dx, or x power n, arc tangent x, tangent alpha x, because it's hard for you to find the antiderivative of ln. It's very hard to find the antiderivative of arcsine, arctangent. You can find the derivative of arctangent, but not antiderivative. Okay. So in this case, normally you just let u equals ln, or u equals ln x, or sine inverse, or tangent inverse, which is arcsine, arctangent. Okay. And you do dv equals x power n, then you can solve for v here. Okay, this is what you do for the second type of integrals. The previous one for the x sine, for the xn sine x, sine ax, because we can find the antiderivative for this one we cannot find the antiderivative for ln, so that's why we do this way. Okay, now there's another one which is the most difficult part. Okay, not this one. I want to try one, see what happens. So now example, I want to try e to 2x sine 3x dx. use Tabular method here. Try it. I'll give you a little bit hint, okay? You think about it. If you do u equals this, you do v equals this, then dv it will never change anything because e to 2x and continue e to 2x, okay? But let's just give you a little bit hint. Suppose u equals sine 3x and dv equals e to 2x. I think the other way around it should be okay too, but just more steps. So, what do you got? Can you stop anywhere? It seems like you can get a 0. But do you see a alternation, like a repeat back again? So what we do now here, I think everyone got that. Derivative, the u you do derivative, the dv you do antiderivative. So derivative of sine x, sine 3x, 3 cosine x, cosine 3x. And the antiderivative for this one is e to 2x over 2. And the derivative of 3 cosine goes back to negative 9 sine 3x. The antiderivative of this is e to 2x over 4. How many of you got this? This raise up a hand. Okay, so most of you got this, exact this, okay? So now, I want to stop right here. I want to stop here. Okay? Why do I stop here? Because if I keep doing, I cannot stop. There's no ending. Derivative sine, cosine, sine, cosine, sine, cosine. But why do I think I can stop here? Because if I stop here, this goes back to itself. I have something goes back to a coefficient of the antiderivative itself. I can just shift that to the left side. So what's the meaning of that? Let's continue to look at this. Okay. So still plus, minus, plus. Okay, don't change that sign. This one is already the derivative sign. I don't really. You have to keep that. Okay. So plus, minus, plus. So this is the uv minus uv du thing coming from, and then this is goes to here and that. All right. So if I write it out, it's going to be equal. So the antiderivative is sine e to 2x, e to 2x sine 3x. I want to repeat that here because it's too far away from there. The reason I do that, I want you to look at something. So that equals sine 3x e to 2x over 2. Okay, you just cross and multiply that, and minus 3 cosine 3x e to 2x over 2. No, wait. 4. My bad. So this one and this one, right? E to 2x over 4. This 2. So this 2 is over 4. And then plus, well, plus minus is minus. Minus 9 over 4 sine 3x e to 2x dx. Because this is coefficient, 9 over 4. So now I have this thing coming out. Okay? Maybe I just write this as e to 2x sine 3x. Because this doesn't, it's pretty much the same. E to 2x sine 3x. Alright? So here's another question. Can anyone tell me what I'm supposed to do here? What can we do here? Can anyone tell me? Anyone? Okay, so if I change something, probably you can tell me the right answer what I want. If I have x equals 5 minus 2 plus 3 plus minus 9 over 4x, what do you think I need to do now? Solve for x. If it's like this, how do I solve for x? Oh, you bring this one to this side, right? Look at this one. Look at the antiderivative here. What do you have? You have exactly the same integral. You have exactly the same integral by just the coefficient. You can bring the whole thing over to the left side. You have the integral, right? So bring the whole thing over to here is just the same thing. So you add both sides with 9 over 4, the whole integral. So it's going to be 1 plus 9 over 4, the whole integral. Because the whole thing, you just add the coefficient. There's 1 here. Okay. So it's e to 2x sine, bring it over is plus dx equals, I can combine these two. Okay, you can combine common denominator of these two, combine those two. Is 4. More common denominator 4 times 2, 2 times 2 is 2, and you have e to 2x is common factor, so e to 2x factor out, and sine 3x minus, oh no, I don't factor 2 out, just the ex out, sine 2 sine 3x, 3 cosine 3x. Okay, just the factor e to 2x out, because the common factor here. Common factor multiply the top and the bottom by 2, both of them by 2 here. So I have 4. Okay, so just combine those together in one fraction. Now, this is 13 over 4. This whole thing, this gives you 13 over 4, because it's just a coefficient. 4 over 4 plus 9 over 4 is 13 over 4. Okay. So 13 over 4, this is the 4. I can multiply both sides by 4. The 4 can cancel out. We have 13, the whole integral, e to, because the 4 can cancel, you multiply this by 4, multiply this by 4, the 4 goes away. So you just have 13 e to 2x sine 3x dx equals e to 2x 2 sine 3x minus 3 cosine 3x plus c. Okay. Then you have e to 2x sine 3x dx equals 13 e to 2x 2 sine 3x minus 3 cosine 3x plus c. That's it. Okay. Yes? To here? You mean use the uv minus v du on this whole thing? Can we use the u? Can we use u dv equals uv minus v du to all of this problem? Yeah, you can, but it's more complicated. It takes more time, and it is more time consuming, because uv minus v du only give you two of lines. For example, if you do uv minus v du, it only give you up to here. Okay. Then you have to use the uv minus v du, use the integral parts again, you get to here. Then you use the integral parts, you get to here. So every time you only bring you one more step. This one is kind of continue using the uv minus v du several times. Does it make sense, Lacey? Yeah, this is kind of like a simplified way, kind of like simplified a process of using the integral parts. Okay, so our last example should be the most most difficult one, a little bit tricky, but all the thing is not hard at all. So you can go back and review the last example again and finish your try some homework. You have a lot of practice in your homework. Okay, so the third type of question is whenever you have e to ax sine bx dx. This is the last one we just got. Okay, or e to ax cosine bx dx. Whenever you have those two integral, okay, you let u equals itself sine bx, because you take twice again, it goes back to itself again, and the dv equals e to power ax dx. But you know dv just that one. Okay, use the Taubiner method. You can finish it that. That's the whole section of Taubiner method. It should be pretty simple of using the Taubiner method. Very straightforward. One set of u dv, one side do derivative, other side do antiderivative, plus minus, you are done. Okay. Except the last one, you have one antiderivative goes back to itself. This is a particular one. You use this method, but we cover that as well. You're gonna do more practice. Don't forget the quiz. So today, tomorrow, and finish the quiz, and you have an idea of the test problems. Okay. So see you tomorrow. We're gonna do trigonometry tomorrow, trigonometry statistics, trigonometry integrals. Okay, I'll see you tomorrow. Thank you.